Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar. We are going to get started right on time here. My name is Johanna Zetterberg. I'm with the U.S. Department of Energy's Office of Electricity, and I'm part of the core team that supports the NARUC-NASEO Task Force on Comprehensive Electricity Planning. On behalf of the team, thank you for joining us today. This webinar is part of a series developed for 16 diverse states who are members of the NARUC-NASEO Task Force on Comprehensive Electricity Planning. These states are now midway through a 2-year facilitated journey to develop state-led pathways toward a more resilient, efficient, and affordable grid through improving the alignment of electricity system planning processes. The slides from today's webinar will be posted on the resources page of the task force website at naruc.org/taskforce, one word. The resources page contains a resource library of previous webinars in the series, as well as curated publications organized by key themes relevant to the topic of comprehensive electricity planning. The resource library is available to all NARUC and NASEO members, as well as the general public. We have a great speaker and topic today. Paul DiMartini from Newport Consulting Group will discuss the latest volume of the Modern Distribution Grid project. And now I'd like to turn it over to Tricia DeBleeker from the Minnesota PUC, who will be moderating our discussion today, and will go over some housekeeping and logistics items, as well as provide a bit more introduction on Paul DiMartini, our speaker. Tricia, over to you.
All right, great. Thanks, Johanna. First, I'd like to welcome all the attendees to today's webinar on the DOE's work on the DSPx Modern Distribution Grid volumes. I'm personally excited to be able to introduce Paul DiMartini today, as the DSPx guidebooks and Paul himself have been an invaluable resource to the Minnesota Commission staff. Paul is a leading architect on the business, policy, and technology dimensions of a more distributed power system. He has been an industry resource to utility regulatory and government clients on utility business strategies, system planning processes, and grid investments. Over the past 9 years, Paul has supported 12 of the largest 15 U.S. electric utilities, as well as international future grid efforts. He has also contributed to over 10 states' regulatory guidance on grid planning and modernization, Minnesota included. And so Paul is co-lead for DOE's Modern Distribution Grid, this DSPx initiative, and is a principal contributor to the DOE's Distribution Resilience Planning and TD Operational Coordination projects. So in my view, and important for us today, is that the DSPx guidebooks are useful tools to help with some of the considerations that I've seen that have been emerging out of the NARUC-NASEO Integrated Planning Task Force. Essentially, how the level of grid modernization on any given utility system, and for what purpose that modernization effort was intended, affects or enable a distribution system planning process. So specifically in Minnesota, we have found the DSPx guidebooks to be a tool to assist us both in understanding and evaluating grid modernization investments, how they fit together and what should be considered in our analysis, but also we use these guidebooks in directing our utilities to reference and look at when they were making filings before us. So that has allowed both us as the regulator and our utilities to come to a table with a common language and shared understanding of the basic frameworks for consideration. So as we work through these complicated system changes, it helped us further the conversation to a point we weren't at yet. So as for logistics, and before I kick it over to Paul, if you have questions as we move along, please type them into the chat box using the control panel in the GoToWebinar program on your computer. We will accept and ask questions as we go along, so feel free to chime in when you have a question, and we'll also set aside a few minutes at the end to take questions. However, we will be keeping all lines muted throughout the webinar. So with that, Paul, welcome, and please take it away.
Thank you, Tricia, thank you to everyone for the opportunity to share what we've been doing on the DSPx project in the second phase. So just for a little background, some of you may be familiar with the next generation of distribution system platform. That was the original name, and that's how we got the acronym DSPx. The project was introduced in 2016, and it was intended to, at the behest of the California and New York commissions, which then extended to the Hawaiian and DC commissions, to look at a set of materials to help with thinking through the issues related to grid modernization. We also included some dimensions that tied to the work that we did as well for Minnesota on integrated distribution planning to try to provide a comprehensive view of how to think about both planning and then from a distribution standpoint, then moving into thinking about a structured way to consider the types of modernization investments that would be necessary. That work resulted in 3 volumes, volumes 1 through 3, which were released in 2017 and have been fairly widely used, as was mentioned, across the country. It's also being used by EPRI with their work with utilities and several leading consulting firms in their work on grid modernization. Coming out of that activity in 2017, there was a recognition that we could take a little further look down the road, as the original work was very focused on a 5-year horizon that the states and commission that we were working with initially were focused on, which was really kind of looking out to 2020 or so. And so really 2 things. One was looking further down the road out to say 2030 or so on, as many states started to look at 10-year horizons for longer term distribution planning, and then therefore what grid investments might be necessary, as well as orienting the volumes and evolving the work to be generally applicable anywhere in the United States. So trying to be a little broader in the view and a little more attuned to the needs of other states beyond the initial 4 states. Still being relevant to the considerations going on in the original states, but recognizing there was a new set of states that had needs looking at modernization from a number of other different dimensions. So again, looking to broaden the applicability of the document. As part of that, we broadened the number of states and a new set of states that work with us to develop this, as well as other utilities that also then continue to work with us as well. So kind of expanding beyond the initial set of folks that work with us on the first set of volumes. We also updated the cost effectiveness framework, which I'll touch on in this presentation. Just in terms of structure, we're just in the final stages of finalizing this strategy and planning guidebook, which is what I'll be focusing the presentation today on. And then we did update volume 1 and 2, and that is currently in final review with the Department of Energy. The volume 3, the strategic, which is kind of a strategic planning, was called the Decision Maker's Guide. We did not update, so that volume still is, and it's available on the, which I'll show later. It's available on the Pacific Northwest National Lab Grid Architecture website. We are also going to be developing a summary and user's guide. This is something that the working group with regulatory commissions that we've had in the second phase identified at the beginning of the year as a need. And the Department of Energy has engaged RAP, Carl Linville in particular, to help develop that. So we kicked that off actually yesterday. So that will be in development and available targeting the first quarter of next year. The guidebook and the updated volumes are anticipated to be able to be posted and available publicly in January, if not maybe February, but certainly within the first couple months of next year is the target. In terms of the overall guidebook, we did expand kind of the view of what the objectives are. Some of you may be familiar, there was a particular focus around reliability, and then with operational safety and operational efficiency, and a particular focus on distributed resource integration and utilization as 2 separate bubbles. What we've looked at is the growing need and focus around resilience in addition to reliability, and then we collapsed sort of the DER integration and utilization into a single bubble. So this diagram has been updated really to emphasize the fact that reliability and resilience for many states is a particular importance, whereas when we started the first phase, the DER integration utilization was kind of a prominent dimension for the initial states. So this is to look at this a little more broadly. This diagram is one that I've been developing with the work with Johanna Zetterberg, coming out of the distribution resilience planning and some of the work that we've been doing in support of Puerto Rico and a few other states. Michigan most recently made a presentation. But the idea of really trying to understand the relationship between broader distribution investments and those that relate to grid modernization, but realizing that all of these are building blocks towards that modern grid. So the elements related to basic infrastructure, those elements related to distribution automation and design practices, and then more advanced technologies, and so on as we get into sort of the realm of grid modernization. But the realization that in many states that are looking at these questions around distribution planning, grid modernization, reliability, resilience, these all interplay with each other. And so understanding the relationship of these investments to each other, it becomes particularly important to understand how this develops. I think as many of you are quite familiar, we have multiple planning processes in the distribution space. There's asset management or asset planning, which tends to focus on the basic infrastructure and dealing with sort of fundamental safety and electric code compliance issues. Then we have reliability and resilience planning that starts to look at circuit configurations, does overlap with aging infrastructure replacement, and then looking at distribution automation, resilience, and reliability can also then carry over into looking at distribution automation and grid modernization realm. So there's no clear delineation between many of these planning efforts. That they do tend to bleed over between each other, and so parsing these out and understanding the relationship and which planning process is addressing which part of this and over what time horizon is also something often that many of you have found in your efforts, but or you may find as you go forward considerations of trying to understand how these all interrelate, how the utilities are tackling the need to assess all these dimensions in a cohesive way. I point out on the chart, and you may have seen similar sort of pie charts for where distribution capital investment may be spent. The dark blue, the colors relate to the stack. So the dark blue really do touch on those areas that are in the asset planning arena. And then you have the lighter shades of blue that tend to show up in either reliability and resilience or grid modernization. They can, as I said, cross over into different domains depending on how the planning processes evolve within the particular utility. The public works, which is basically relocating lines from one side or the other, or maybe undergrounding at the request of a city or a county, or new customer service requests tend to be outside of those planning areas, other than accounting for it in a budget process. This diagram, which you may be quite familiar with, is the diagram I originally developed for Minnesota in the Integrated Distribution Planning paper several years ago. What we've done is started to update this to include the resilience threat assessment at the distribution level. And what you'll see in the new guidebook is an expansion of the discussion around integrated distribution planning to incorporate the resilience threat assessment dimension and resilience planning as part of it. We're also highlighting the distribution asset management, which didn't get as much attention earlier, but the role that that planning process within a utility plays in feeding into the grid modernization roadmap and the like is an important dimension that we are highlighting as well. On this slide, it just expands, it drills down a little bit deeper. This is a slide that we developed in conjunction with several regulatory commissions and trying to understand the relationship both in the the basic process, what was on the other slide, and this slide where how these different planning efforts, both the near-term asset planning that happens typically on an annual basis, the near-term distribution planning, which happens on an annual basis for most utilities with about a 1 to 2 or in some cases a 3-year horizon, and then the longer-term planning that happens maybe every 2 years or 3 years, depending on either the utility or the regulatory requirements, and that typically has a horizon of 5 to 10 years, depending again on jurisdiction and the utility. But the relationship of those planning efforts feeding into the two-step approach that we outlined, the grid modernization strategy development, which is a longer-term view, and the grid mod implementation plans, which tend to be a nearer term, a 5-year, up to 5-year, but could be 3 to 5 year kind of plans that happen. And the recognition that these include feedback loops, so that there's continuous updates over time as the investments get made, as conditions change, as needs may evolve in terms of coming out of the planning based on forecasts and based on policy objectives and other planning criteria that may be developed. One of the things coming out of the resilience work is trying to clarify some of the language about resilience. And one of the things we've identified is that it may be useful for us to think about defining the term resilience in really 2 dimensions that we generally describe in the industry. One is we use the term resilience to refer to events, that is, whether we're talking about largely major events, and distinguishing that from a reliability event, which is generally less than 24 hours, and they're measured by the IEEE metrics, so you're probably quite familiar with the SAIDI, KD type metrics. But recognizing that these events are on a continuum, and so there's not really a bright line, if you will, and how you plan for these events within the dimension of thinking about reliability and resilience is also on a continuum, as in many cases you're talking about trying to prevent or mitigate the impacts on similar sorts of issues, that is poles breaking or wire down or transformer failures and the like. Only in a resilience event you're talking about a lot more of those potential impacts over a greater area, resulting in a longer outage duration. But from a planning standpoint, it's important to think about these things together, because some of the same investments or investment strategies are going to be similar in some cases. There are some differences that need to be considered as well, but it's a helpful way to kind of think about it. There is another way of thinking about resilience, and that has to do with the characteristic of the system to be able to withstand an event, and that's a dimension that we're looking at pretty closely in the resilience planning effort that Johanna's leading. Now, in terms of DSPx, we introduced back in 2017 a taxonomy, a structured approach to thinking about how you develop functionality that you need for a modern grid, and then what the kinds of technologies that we use to address it. We firmly believe in starting with what are the objectives, and then working your way systematically to then determine what technology. As my colleague Jeff Taft likes to talk about, his father once, and they were building a house, said, "What's the first thing you do when you build a house? Do you start to hang the windows, or do you pick up a pencil?" Of course, the answer is you pick up a pencil and determine what kind of house you want, and then you ultimately decide what kind of window you want to hang. But we often, in these discussions about grid modernization, start with a technology discussion. What is, maybe somebody's describing an ADMS that they want to use, an advanced distribution management system, or they want AMI, smart metering technology. And really the way we approach it is, well, what are you trying to accomplish? And from that, you can then determine what's the appropriate functionality, and from that, you can determine the appropriate technologies to meet that functionality and ultimately those objectives. We also think it's important to be able to have traceability, so that when you implement some technology, you can trace that ability of that technology to, its ability to deliver a capability all the way back to the objectives and ultimately to the principles for that particular jurisdiction. So these are things that we we've incorporated in this, and it's been fairly widely used around the industry so far. But what I would point out is that we have taken an effort to try and streamline this, because we had it a little more complicated before, and now we've kept it to 4 levels, which I'll get into in a little bit. So we streamlined this and recognize that really objectives start with the principles or mission from that particular state or jurisdiction, as the case may be. Now, one of the things with grid modernization, as I mentioned before in the Venn diagram, is that we have a number of different aspects that need to potentially be considered. So we have those broad objectives that were represented in the Venn diagram: the safety and operational efficiency, the reliability and resilience, and the DER integration and utilization. But we also have these general categories of capabilities related to some areas within the operation of a utility, and that is starting with the distribution planning area, looking at that from an integrated distribution planning dimension, as illustrated earlier. Grid operations, that's the real-time grid operations, and then market operations. And market here is a fairly broad term. It means things like non-wires alternative, or to the extent that distributed resources are participating in a wholesale market, what might the distribution utility need to have in terms of its capability to be able to manage that. It can also be other programs that the utility operates and what systems they may need to have to interface with distributed resources participating or providing services to that utility, as in the cases for some vertically structured utilities that are also, buying ancillary services from distributed resource aggregators. So we put the structure together just to help us frame where the areas where there existing practice and information, and where are the new areas that we need to look at. In the case here, where reliability and resilience, the blue, the new areas are really around resilience and reliability for planning and operations. There's a lot of experience there. There's always some new things, but generally speaking, that's a pretty mature area. So where we've tended to focus in our efforts, although we capture across this whole space, most of what we've been looking at, particularly on the technology side, as we looked in volume 2, was really in those areas in the blue. Now, one of the things that we did, and this is an update from what we proposed in the first phase in volume 3, is we updated a sequential decision, sort of stepwise decision guide for thinking about grid modernization. So we broke this into 2 parts, a strategy part and an implementation planning part. On the strategy part, it starts with the organization or the state's or commission's mission and principles, and then it's the identification of objectives in addition to any scope or timing considerations related to that. And I'll get into an example. Grid capabilities and functionality that will be necessary to achieve those objectives, and then some architecture and strategic architecture considerations and development of strategic roadmap, including a conceptual cost estimate. So that's what's articulated in the guidebook. Now there's a series of, there's a chapter 3 on this. Chapter 4 gets into what's in blue here, the implementation plan. So how are use cases and requirements developed? These are at a detailed level. Then the detailed designs that come out, the choices that are being made specific to meet these overall objectives and capabilities that have been identified in a strategy or some other venue, and then the ultimate technology selection, and then how are these technologies going to be deployed over time. So the new volume, the guidebook, really covers this whole dimension, trying to articulate elements of each of these 7 steps, including step 0, so really 8. Mission and principles, just to give you a little sense of this. These are some examples that are in the guidebook. So we tried to bring in more relevant information from various states as we've moved forward. We have a lot more examples to be able to refer to than we did when we started this work back in 2016. So here we have a couple of examples of mission that that came right from what the states have themselves in Ohio and Missouri. And then in terms of principles, this was what Hawaii put forward in terms of what they saw their grid mod principles. So just to give some examples, and we've tried to illustrate throughout the document to show how people have approached this. Now the taxonomy, as I mentioned, we simplified, so now it's basically 4 levels, not including the principles, which already you will have. So here, objectives, then capabilities, functionalities, and technologies. And for each of these, we've developed a generic set of categories of, for example, objectives, and then capabilities, functionalities, and technologies, so that you can start to see how these relate to each other. And so these aren't meant to be prescriptive in any way. This is just to give you some reference categories to consider if they're relevant. If they are, what we've been able to do is start to look at how these would then map. So for example, if your state has a particular objective around reliability or resilience, you can start to see, for example, on how that in the orange columns relate to the green rows, and the dots represent where there's an intersection that capability would be necessary to support that objective on some basis. So it's a way to think about what I may need to have to achieve that objective. This is useful because the next thing you do is then link those capabilities to particular functionality that we've identified in volume 1 to what's shown on the right-hand side, those blue columns. Then you can see the different functionality that may be required with a particular capability. So for example, if we look at resilience back on the left-hand side, scalability is a dimension, that a capability that's necessary for resilience. And then if you go over to the right-hand side, you'll see that scalability has multiple dimensions in terms of functionality. So scalability with respect to forecasting, scalability with respect to long-term planning, interconnection processes, reliability and resilience criteria. These are all elements that need to be thought about in terms of how you would be able to scale whatever processes or technologies that are going to support those activities, that functionality. Scalability is a capability that's going to be required to be considered by the utility in their planning efforts. So that's how these matrices work. It provides a way for you to look at how to trace back to a particular objective, whether or not a proposed plan addresses these dimensions or not. We also have matrices from functionality to technology areas in volume 2, in the updated volume 2. In terms of taxonomy example, just to give you a sense here, there are 2 examples. One is showing how objectives to capability to function to technology. Here, an objective, this is a common objective, customer choice through information access for small business and residential customers to support decision-making by, say, 2020 or whatever the year might be. The capability would be to provide, one capability could be provide online customer access to relevant and timely information. This would require functionality around remote meter data collection and verification, customer data management, energy management, and DER purchase analysis as potential functions that may be desired, and then a set of technologies that would then enable these things. So this is a sort of taxonomy approach that we look at, and it relates to those matrices I showed a moment ago. Another example is to say, for example, reliability improvement by reducing customer unplanned outage durations, specifically achieving first quartile KD performance by 2020. The capability would be to improve outage identification and customer service restoration. There may be other capabilities too, but this is just one. From that, to do that, you need, in terms of function, fault identification, fault location, fault isolation, service restoration, also known as FLISR. And the technologies to support that are listed there on the right-hand column. So there's a number of technologies that are required to support this these functions and that capability and ultimately that objective. By the way, these technologies also support other capabilities and functions. So they're not only to do this, but they would be able to support more than one function and capability, which goes to thinking about the overall architectural strategy that you would employ here in terms of thinking about the kinds of grid structure or observability, control and protection, communications, analytics and data management, and cyber physical security. So these are the ones we've called out in the new guidebook, and we've discussed in terms of their relevance to thinking about broadly a number of different dimensions and how these support at a core level the kind of capabilities that are generally identified in grid modernization efforts. Of course, what you may need to do will be very tailored to a specific state or jurisdiction or a particular utility, but in terms of general, these tend to be generally applicable in many instances, particularly as we look ahead over the next decade. As part of that, we've previously identified what we believe based on that analysis of which technology categories and functions and meeting what capabilities, that if you look at the number of investments in technology that ultimately support the widest range or really provide this sort of foundational layer that support many different capabilities and functions that are generally identified, the set we've described there as core components really fit that dimension. So these are the foundational components, and then those in the purple and the gold color above are really applications that sit on top of this foundation. So all of the purple elements rely on investment in the blue and in the green areas to be able to operate. And multiple of those applications take advantage of elements in the core component area. That's how this is structured. One of the things we identified and we saw a number of utilities use is to use that diagram, that technology stack it's often referred to, and start to look at where are you in your process. Now, this is at a summary level. You'd obviously want to have much greater detail behind it, but the idea is that in a very quick way, you can start to get a sense of how far along is the particular utility or your utilities in the implementation of more advanced technology to be able to meet the overall objectives. So this is it's a quick way of getting that view. Where you see that there is no block represented from the technologies in the prior diagram, it means that they haven't implemented anything. So that's where there's there's nothing done yet. Those that show just a little bit of color represent sort of percentage complete towards the implementation of a particular technology. In some cases, like in this case, where you have multiple operating companies, it would represent which operating company may have or not, or in aggregate, what the total is across those operating companies. Now, one of the things we also address in the implementation is some discussion about how to think about decision criteria for technology implementation. And so really focused on technology fit and risk, which is a fairly common thing, but we provide some detail there so you understand how, from a technology management standpoint, what the best practices are around this. Customer policy and business priority, obviously alignment with the objectives and the like, and that traceability we talked about earlier. Costs, which you're familiar with. One of the things that is less understood and not always done is organizational capacity, not just of the utility to be able to implement the technology, but sometimes it's really just as important as does the technology provider have the bandwidth to be able to provide that, support that implementation. This is particularly important when dealing with new or emergent technologies for utilities to adopt, say a software system or planning tool and you have a startup that is providing that technology, the startup may not have all the organizational capacity to support what a utility, particularly large utility, may need in terms of implementation processes and the like to bring into their environment. This is especially true when we're bringing technology into an operating environment with very stringent cybersecurity and organizational requirements with respect to process for technology implementation. This is well known. It isn't just unique to the utility industry. This is well known in every industry where you have very small companies trying to bring technology into very large established corporations. It can be quite challenging. Often there are partners that are brought in, and so to be able to help with that transition. But that's something that often is something to consider as well, because otherwise you can end up with delays and cost overruns in a project. One of the things that we have had a lot of discussion with states over the last couple of years is talking about when is the right time to be thinking about different technologies given their relative maturity. In Volume 2, in the update, we have updated where we think technologies are based on feedback from the industry on a classic S-curve. And then one of the things we introduced some time ago, but spending a little more time in this volume to discuss where to think about when to adopt a technology. So not adopting too early, so you're dealing with a lot of those issues. The risk that I was showing on the prior slide, but not too late, such that you're getting something at the end of its life cycle is going to get replaced with something else, so you get this obsolescence risk. So these are things that we do discuss in this document as well. Just to come back again, understanding where grid mod investments fit within this series of distribution investments, and recognizing that it's very important to understand its relationship in the context of the other investments that are underway that in some cases may be outside the scope of the grid mod proceeding. They may be happening as part of a rate case or the like, but it's very important to understand the relationship to these different investments. One of the things you may have seen on the prior slide with the technology stack is that there was two dark green rows, the one below operational communications, which was the physical grid, and that physical grid are the first four arrows that represents those first 4 arrows. So it's very important that these are integrated in terms of planning and implementation efforts. This is just an example out of the Xcel Energy integrated distribution plan. I recommend this one to you because I thought it was pretty good, and not just because I helped support this one, but I think they did a nice job in articulating the planning process and then tying it to how they thought about investment over a fairly long period. This is publicly available. I would encourage you to take a look at it. I'm sure Tricia and others may be able to share more. It's just a good example amongst several that are emerging to kind of get a sense of how people are trying to tie these various planning efforts based on regulatory requirements, and then how are they trying to illustrate the thinking that they've gone through to result in a longer term plan. The other thing we introduced was this cost effectiveness framework. We built on what we provided in 2017. E3 worked with us to both on the original one, but also more closely on this. There's a whole chapter on this cost effectiveness framework that more fully explains how we think that you might consider evaluating different types of grid investment categories with different approaches. We did sync up with Lisa Schwartz and the Synapse folks, Tim Wolf, to align Tim's work with our work. So you will see some consistency in the way that we both discuss it. Tim goes into more detail on the benefit cost analysis, but the two documents will do marry up pretty nicely now. In sum, we have a number of documents that you might take a look at. Certainly the Modern Distribution Grid Report. The original volumes are at the PNNL website. and you can see those. Like I said, volume 1 and 2 are updated and will be posted presumably in January. The guidebook, the new volume 4, often referred to, that should be out January, but no later than February. The Power Forward work out of Ohio is quite good to take a look at. The grid modernization plan from an integrated distribution plan from Excel, so a good reference. The grid mod strategy at HECO is good. They use the original version of material, and then the grid architecture work that sets a lot of this.
Yeah, after that, 2020.
Next decade. All right.
Okay. Hey, also, I don't think I ever.
So that's my presentation. Thank you.
Paul, thank you very much. That was a great overview and update, and several questions have come in while you were speaking, so I'd like to turn to them now. The first is, can you discuss how these principles for distribution system planning need to be incorporated into utility integrated resource planning? Are those always separate silos, or are there utilities that are already doing a good job implementing both IRP and DSPx? Maybe you could answer this from the grid modernization project perspective.
So I would say that maybe just to clarify, I think what we've started to see is the linkage between the integrated distribution planning process and the grid modernization. So those two had been basically separate. I think those are now increasingly, like we see here with the Excel, being brought together. And I think that's been a good step forward. And I think that what we're seeing in Michigan is tying the asset planning part with the reliability and resilience dimensions of asset planning with the modernization, and so that's a nice step forward. And I think over the next year or so, as those plans come out of Michigan, I think we'll see the next generation of that. I think we still have the link between what's happening at distribution and the integrated resource conversion. I think we're still at the leading edge of that. I mean, certainly what's going on in Hawaii, and for disclosure, I do support Hawaiian Electric on their integrated grid planning effort. So I think that's one. We're starting to see some of that in California with the effort there with the commission and the utilities linking those. But I think that there's still more to be done in thinking about how integrated resource planning with the distribution and the distribution investments linked together. I think that's still a work in progress.
Thank you for that. Here's another question for you, Paul. Please discuss the wisdom of investing now in 50-year assets, like a new central station power plant, at a time when new technologies are so early in their adoption curves. Is there any rule of thumb or best practice about spending in some modular fashion so that we can see more and more about how the future plays out while holding various options in ready mode?
Yeah, so my work relates to grid investments and particularly distribution. Generation investments, I think, most definitely there are opportunities to look at modular approaches. I think not to dismiss the question, but to set that aside for a moment, I think in terms of grid investment, particularly in the distribution, I think there are ways to consider both modular investments, proportional investments, as well as better understanding what are core investments that if you look at a variety of future scenarios, that is not trying to predict the future, but rather developing a set of potential futures with different outcomes, and you can get fairly creative about what they may be in terms of trying to look at a range of potential possibilities, and then stress test, using those to stress test a potential investment plan for, say, distribution investments, which have a 20 to 40 year horizon. Still a very long horizon with a lot of potential change coming over the next 20 to 40 years. So I think there are ways for us to be thinking about the use of scenarios to really assess which investments still hold up under those various potential futures with lots of resources of one type or another, say a lot of distributed solar and storage with certain characteristics, maybe a lot of microgrids and so on. But I think sometimes you will see, in many cases, I think you will see that there are a set of core investments that are needed in under pretty much any of those scenarios, unless there's something radically different that may come. And then even if that were to happen, you could still say, all right, what would be reasonable to do in the next 5 to 10 years that would still be, not create too much risk for potential stranded investment. And so you can manage that through a proportional deployment. So that is recognizing the distribution systems, rarely do you need to do a deployment to, say, address distributed resources across the entire system right from the get-go. You can do that in a proportional way that you address those areas where the need is, and you can manage risk in that way too. So there's a number of levers that you can think about, and we've discussed some of those and many of those actually in the guidebook and in volume 3.
Thank you, Paul. Great. Here's another question for you. Are case studies available to explain which utilities are already doing the best with these changes that could be used to help the later adopting utilities to get up to speed faster and better?
That's a good question, and actually one that I think we'll take away from this conversation and bringing to Carl Linville as we develop the summary. Maybe we will be able to highlight which ones we think are quite illustrative and useful for as examples. Well, I mean, we've sort of been doing it ad hoc along the way as new documents get filed, but maybe we can be more systematic about it and incorporate in the summary we're developing. Thank you.
Thank you. Okay, I've got another question here for you. It seems that the grid mod investments and technologies discussed may have faster obsolescence and shorter useful lives than more traditional assets. If this is true, how should regulators account for this in cost effectiveness evaluations?
So yes, generally speaking, a lot of the grid modernization investments are what are referred to as digitalization of the grid. I mean, as in distribution grid, as many of you probably know, a lot of the distribution systems in the US are still fairly analog. We still have electromechanical protection relays and some other devices that are manually operated, like air switches and the like. But we are moving, as part of the modernization, as part of the automation that happened with smart grid and the like over the last 20 years, to more digital-based devices or physical devices that have computing and communications embedded in them. And so yes, the life of those devices can be much shorter than the typical 40 year asset life of physical apparatus or poles and wires. And so those are considerations. Part of what we talk about in the architectural is understanding how to have some modularity related to sort of physical arrangement or from a computing standpoint, so that you can make upgrades to one without necessarily having to touch the other. That is, how do you have some modularity so that you can replace a communication module and not have to replace the whole switch, for example, or that you can change the software in the device without having to touch the device, so that you're not having to, it's a much lower cost proposition. So there's some things like that, but generally speaking, there are some considerations that need to be thought about with respect to the slow cycle nature of most of the physical infrastructure and the fast cycle technologies that are related to this digitalization. There's no simple answer, but there are some techniques, both in terms of the design from an architecture standpoint, and there are some pieces of that we describe in the new guidebook. There's also some considerations, as I was describing, that we talk about in volume 3. But yes, there are some ways to approach this. They're not perfect. They're really risk mitigation approaches.
Thank you, Paul. I'd like to do a quick clarifying question, if we could. I believe it's on slide 20, Paul, although on my screen, I think on the screens of others, the slide number is actually cut off. There's like a black sort of letterbox line on the top and bottom, but I think it's around slide 20. The question is, I know what WAN is. I might be saying that wrong, Paul, W-A-N, but what is FAN and NAN? I think it's the slide right before this.
Okay, so yeah, it's on this one and this one. So in operational communications, there is a wide area network, WAN, a field area network, FAN, and neighborhood area network, NAN. Wide area network refers to generally kind of two types of communications that are used by utilities for operations. One is to communicate from an operating center out to substations, and that could be fiber optic or microwave. In some cases, it's just a plain old telephone system, but most of that's been updated for distribution substations. And all transmission stations, there's broadband communications, but in distribution substations, increasingly, a wide area network that has higher bandwidth and lower latency, that is, have fast signals go back and forth, are increasingly the case as more automation, more information and intelligence and controls are needed out at the distribution substation. So typically there's fiber optic being extended out to distribution substations on some longer term programmatic way, or microwave communication. Field area networks, or I should say the other type of wide area network, are often referred to, say, in an AMI system as a backhaul. That is the cellular communications that that goes from the field area network back to a data center or operation center, as the case may be. That's also considered a wide area network, but that's usually over a third party, telecom provider's network. The field area network is usually referred to as the network that is often between a substation and some point out on a distribution system, and then from that point out on the distribution circuit is a neighborhood area network, which is sort of the last quarter mile, kind of often what is considered the mesh network in a lot of AMI systems that you may be familiar with. Those are often referred to as or at least they used to be a NAN. Some of those technologies, so there'll be a radio on a pole, and that radio goes from the meter to that radio on the pole, and from that point it then goes over a wide area network on this backhaul, say cellular communication back to the utility. In some cases, that neighborhood area network technology can also be used for a field area network, so those can be blended. The field area network idea came about because a lot of SCADA systems use wireless communications to go from a substation out to the field, and those were done through this field area. But I hope I'm not confusing, but the FAN and NAN are getting blurred under the newer technologies that are available in the market.
Thank you so much for that.
Yeah.
Okay. We certainly have more questions in the queue here, Paul, but I know that Tricia had some questions as well. I want to make sure that she has an opportunity to ask those as we sort of near the end of our hour here. Tricia, would you like to ask a question at this point?
Sure, thanks, Joanna. I've tweaked my question a little bit, Paul. I think, as a regulator and as we're oftentimes, thrown into a docket or a case with an investment before us, I think with the different variations every state is in within these different stages of grid modernization, what's your advice to states in how to apply this at different phases of their process? So I typically look at it as essentially early planning. There's a pre-authorization for prudence, or all the way down into like a retroactive cost recovery request. What's your takeaway to states on how they could apply this at various stages?
Thanks. Yeah, really good question, and one that we were really wrestling with as we developed this and working with several New England states as we were in what we call the practicum. So really working closely with them to really refine our thinking on this. So, to your question, Tricia, we think that for example, often a commission may get an implementation plan, a request for funding, whether it's through a rate case or a separate application. And so what we would suggest is that you may not already have a strategy. There may not have been a grid mod strategy like the one we referenced that Hawaiian Electric put together, or say the California DRP filings that indicated some conceptual roadmap for investment, or what the New York Commission did on the DSIP, what the utilities proposed in terms of what they saw coming over the next 10 years in terms of types of investments, or for example in the Excel, what they showed. You may not get all that, but what you can do at a minimum is, when you get an implementation plan or request for funding, is be able to then, if it isn't already provided, ask these questions about that would get to what would be in the strategy. So what were the objectives that they were aiming this solution to? Because at this point, when you get this implementation plan or application for funding, it's basically to hang a window. So the question is, well, what is the house that you're planning, that you're thinking of, that you're putting this window on? So what were the objectives? How does this satisfy objectives that they think were met? And presumably that they can articulate what those objectives and capabilities and the functionality needed, and then you can evaluate that logic, whether you think this is necessary to achieve those, and whether those objectives and capabilities comport with public policy or customer need. They should also be able to tell you, from an architectural standpoint, the kind of considerations we raise in volume 3 and in the current volume, the new volume, the kinds of things that they ought to be thinking about. So had they considered how this is going to support multiple other applications down the road? How are they thinking about the scalability? How are they thinking about the question that was asked a moment ago about technological obsolescence, or the relationship between the physical asset and say digital, any digital components that are incorporated? So have they thought about that? So even if you get an implementation plan and you don't necessarily have this strategy at a time, you can ask questions that get to the elements that are in this strategy. Obviously, if you're at a point where and you're going to implement a longer term distribution planning cycle, I would incorporate in that a strategy requirement to do what we're calling here in the steps 1, 2, and 3. I would incorporate that as part of the requirement. Then that way, that'll help line up, subsequent requests for funding that would come after that. But you can definitely start with, addressing these kind of issues as part of consideration of a specific implementation plan, even if you don't have the other, and then pick this up, pick the strategy part up later. Because as we showed earlier, this is a cyclical dimension, so the strategy should be updated at the time that the long-term distribution plan is updated.
Great, thanks, Paul.
Sure.
Paul, I think we probably have time for maybe 2 more questions. And thanks so much for answering all these great questions. Here's one that pertains to slide 21. And the question is, slide 21 suggests there might be some best pathways towards maximizing value while minimizing cost. Can we say anything about best practices in which spending should come first, second, third? Question mark, question mark.
So which slide? I didn't quite.
Yeah, it was slide 21 or around there.
Okay.
And the question is about.
Thank you.
Yeah. So the questioner says that slide 21 suggests there might be some best pathways towards maximizing value while minimizing cost. Can we say anything about best practices in which spending should come first, second, third?
Well, fundamentally, we think that, and this gets to, it's a really good question. So I think what we would look at is the core elements, the core components really are those, if you're going to look at the series of investments that need to be made, they really ought to be thought about in that context. and kind of building from the bottom up in terms of this technology stack. One of the things you want to be careful about is layering on technology when you've got the underpinnings, that is the physical grid, the operational communications, are going to need to be replaced, because otherwise, in many cases, you're going to end up spending twice on the installation of devices. So if you put out automated field devices on poles that are going to be replaced in 2 years, it's going to cost you to reinstall those devices again. And installation costs for field devices are generally somewhere in the 3 to 5 times the cost of the equipment. So you definitely want to avoid doing things twice. So you definitely want to optimize that and think about the relationship between these in terms of sequencing. Another thing you want to look at is you want to understand your needs around, for example, sensing and measurement and these other data before you pick your communications. But you definitely want to have your communications installed before you start putting sensing and measurement devices out. Because if you just hang the sensing and measurement devices and you don't have your communications picked, there's 2 problems. One is they don't work until you have communication. And the second is most of these devices have proprietary interfaces, unfortunately, because the vendor community has been pretty resistant to interoperability, unfortunately, and open standards. And so one of the things is you need to know what communications you're going to try and connect these devices to each other. So it's really important to know these things as you think about the sequencing of your investments through this.
Thank you so much, Paul. Well, we are at time, and so we'll conclude the webinar now. I want to thank Paul and thank Tricia and NARUC-NASEO for hosting this webinar today. As a reminder, the slides will be posted on the naruc.org/taskforce website. And please be in touch with the organizers with any questions you may have. And we will close it out now. Thank you very much. Goodbye.